Type RHH and RHW cables can indeed be installed without a raceway under a raised floor in a computer room under specific conditions. These conditions primarily revolve around the nature of the underfloor space itself. The most critical requirement is that the underfloor area must not be used as a plenum. A plenum is a space used for environmental air handling, forming part of the ventilation system. If the underfloor area functions as a plenum, then installing RHH or RHW cable without a raceway is not permitted due to fire safety concerns. Additionally, if the underfloor area contains air handling equipment, the installation of RHH or RHW cable without a raceway is also prohibited. Now let's consider splicing and tapping. Splices and taps in type RHH and RHW cables necessitate the use of an approved enclosure. This enclosure serves several crucial functions. Firstly, it provides mechanical protection to the splice or tap, shielding it from physical damage. Secondly, it offers electrical insulation, preventing accidental contact and short circuits. Thirdly, it contains any potential arcing or sparks that might occur at the splice or tap location, mitigating the risk of fire. The enclosure must be specifically listed for use with the type of cable being employed, in this instance, RHH or RHW. This listing signifies that the enclosure has been tested and found suitable for use with these cable types. The installation of the enclosure must adhere strictly to the manufacturer's instructions. These instructions provide guidance on proper mounting, wiring connections, and other critical aspects of the installation process. Ignoring these instructions can compromise the integrity of the enclosure and increase the risk of electrical hazards. When dealing with DC feeds, there are additional considerations to bear in mind. DC feeds, such as those supplying power from a rectifier to a phone switch and batteries, should be installed in a manner that minimizes the potential for short circuits. Short circuits in DC systems can result in substantial current flow, posing a significant fire hazard. To mitigate this risk, several precautions should be taken. Firstly, cables should be securely supported and protected from physical damage. This can be accomplished by using cable trays, conduit, or other appropriate support structures. The support system should be designed to withstand the weight of the cables and any potential external forces. Secondly, splices and taps should be executed using approved materials and techniques. This includes using connectors and splicing methods specifically designed for DC applications. These connectors and methods typically provide enhanced insulation and mechanical strength compared to those used in AC systems. Thirdly, the entire installation should be meticulously inspected and tested by a qualified electrician. This inspection should verify that all cables are properly supported, all splices and taps are correctly made, and all grounding connections are secure. Testing should include continuity tests, insulation resistance tests, and voltage drop measurements to ensure that the system is functioning safely and effectively. It is critical to consult and comply with all applicable electrical codes and standards. These codes and standards provide detailed requirements for the installation of electrical systems, including those involving RHH and RHW cables, raised floors, and DC power supplies. Failure to comply with these codes and standards can result in serious penalties, including fines and legal action. Now let's delve deeper into the specific characteristics of RHH and RHW cables. RHH stands for rubber heat resistant, while RHW stands for rubber heat and water resistant. These cables are insulated with a thermosetting rubber compound, which provides excellent electrical insulation and resistance to heat and moisture. They are commonly used in a variety of applications, including power distribution, lighting, and control circuits. Both RHH and RHW cables are suitable for use in dry and damp locations. However, RHW cables are also suitable for use in wet locations, making them a more versatile choice in some applications. The ampacity, or current carrying capacity, of RHH and RHW cables depends on several factors, including the conductor size, insulation type, and ambient temperature. It is crucial to consult the National Electrical Code or other applicable standards to determine the appropriate ampacity for a given installation. When selecting an enclosure for splices and taps in RHH or RHW cables, several factors should be considered. The enclosure should be sized appropriately for the number and size of conductors being spliced or tapped. It should also be made of a material that is compatible with the environment in which it will be installed. For example, in corrosive environments, a stainless steel or fiberglass enclosure may be necessary. The enclosure should be properly grounded to ensure electrical safety. Grounding helps to prevent electric shock and reduces the risk of fire in the event of a fault. The grounding conductor should be sized according to the applicable electrical codes and standards. In addition to the above considerations, it is also important to ensure that the installation of RHH and RHW cables under a raised floor complies with all applicable building codes and regulations. These codes and regulations may specify requirements for fire resistance, ventilation, and other aspects of the installation. Failure to comply with these codes and regulations can result in costly rework and delays. When working with electrical systems, it is essential to prioritize safety. Always de-energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Never work alone, and always have a qualified electrician supervise any work that is beyond your skill level. Remember, electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. In the context of a computer room, maintaining proper grounding is particularly crucial due to the sensitivity of electronic equipment. A well-designed grounding system minimizes the risk of electrical noise and interference, which can disrupt the operation of computers and other sensitive devices. The grounding system should comply with the requirements of the National Electrical Code and other applicable standards. It should also be regularly inspected and tested to ensure that it is functioning effectively. In addition to grounding, surge protection is also essential in a computer room. Surges in voltage can damage sensitive electronic equipment, leading to data loss and downtime. Surge protective devices, or SPDs, should be installed at the service entrance and at other strategic locations throughout the electrical system. SPD diverts surge current away from sensitive equipment, protecting it from damage. The selection and installation of SPD should be done by a qualified electrician. Regular maintenance is crucial for ensuring the long-term reliability and safety of an electrical installation. This includes inspecting cables for damage, tightening connections, and testing grounding systems and SPD. A qualified electrician should perform regular maintenance at intervals recommended by the manufacturer or by applicable standards. Proper documentation is also essential. Maintain accurate records of all electrical work performed, including cable types, conductor sizes, enclosure locations, and test results. This documentation can be invaluable for troubleshooting problems and for ensuring that the electrical system is properly maintained over time. Now let's talk about the specifics of the 24 volts DC system you mentioned. While 24 volts is considered a low voltage, it can still pose a shock hazard, especially in wet or damp conditions. Therefore, all of the same safety precautions should be followed as with higher voltage systems. The selection of conductors for 24 volts DC system should be based on the ampacity requirements of the load and the voltage drop limitations of the circuit. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code provides guidelines for calculating voltage drop and selecting conductors that are appropriately sized. When installing a 24 volts DC system, it is essential to use components that are specifically designed for DC applications. This includes connectors, circuit breakers, and power supplies. DC-rated components are designed to handle the unique characteristics of DC current, such as its unidirectional flow and its tendency to cause arcing. The overcurrent protection for a 24 volts DC system should be sized according to the ampacity of the conductors and the rating of the equipment being protected. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current in the event of an overload or short circuit. It is crucial to select overcurrent protection devices that are appropriately rated for the specific application. The batteries in a 24 volts DC system should be properly maintained to ensure their long-term reliability. This includes regularly checking the electrolyte level, cleaning the terminals, and testing the battery's capacity. Batteries should be replaced when they reach the end of their service life to prevent them from causing system failures. In summary, installing RHH and RHW cables under a raised floor in a computer room requires careful consideration of several factors, including the nature of the underfloor space, the need for approved enclosures for splices and taps, and the specific requirements of DC feeds. By following all applicable codes and standards, and by taking all necessary safety precautions, it is possible to create a safe and reliable electrical installation. Keep in mind to prioritize the safety of your equipment and personnel.